Hello, I welcome you all. The problem reads if a force over F equals to 50 pounds is applied to the pads at A and C, determine the smallest dimension D required for equilibrium if the spring has an unstretched length of 1 foot. This problem is coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So we have this system here, and is symmetrical both in the x and in the y direction. Is symmetrical about this axis. It is also symmetrical about this axis. Okay, so we have this force F, been told is 50 pounds. This F is 50 pounds. So I've been asked to determine the smallest dimension D required for equilibrium if the spring has an unstretched length of 1 foot. So what we're going to do is we're going to use the joint method at A, sum up all the forces using the equilibrium equations. Then we'll move to joint B, do the same, and then solve the equations simultaneously. Right, so we have the number of unknowns here. So let's start with joint A. So we have something like this. This is A. We have this force, which is 50 pounds. And then we have this member AB, okay, experiencing some compression force like so. So since this structure is symmetrical, we expect the force in AB to be equal to, the force AB is going to be equal to AD, okay, which is going to be equal to BC equal to CD. All right. So let me call this equal to T. So this is T, this is T. And then we have the slope. The slope for this, we have the rise of D. The hypotenuse is 1. And then the run is root of 1 squared minus D squared. So 1 squared is 1 minus D squared, like so. So this is the slope. So we can apply the equations of equilibrium in the x direction so that we find value of T. So we'll say summation of forces in the x direction equal to 0. This direction being our reference positive. So we have 50 minus 2t, since these are the same, 2t times root of 2t times the root of 1, this is 1 squared, which is just 1 minus d squared, divided by 1 equal to 0. So if we are to make t subject to a formula, it becomes t equal to 50 divided by 2 root of 1 minus d squared, which is equal to 25 root of 1 minus d squared, right? Okay, so we have one equation, the value of t. So we say t is the same throughout. So we are going to again use joint. We are going to go to joint B. Joint B has a similar properties to joint D. So let's go to joint B. Joint B, so we have this value of t here, and we have another t there. Okay, the slope is the same. Right? So we have D, we have 1, and then we have 1 minus d squared. Then we have another force from the spring. Look at this spring. Before the force was applied, before 50 pounds was applied, and before the spring was stretched, its unstretched length was 1 foot. So immediately it was stretched, you expect it to exert, um, you experience it to undergo some tension, right? The spring will have some tension. So at joint B, expect some tension in this manner like this. Okay, so we are going to call this spring force S, right? So we know that according to Hooke's law, the spring force is equal to the spring stiffness times the change in the length of the spring. And S itself, which is the change in the length, can be written as L final, the final length of the spring minus the original length. And we know that um, the original length or the final length of the spring is right now 2D. Okay, this D and this D, right? And then the original length, which is the unstretched length, is 1 foot. Okay, that's what we've been taught. Therefore, S is going to be equal to 2D, okay, minus 1, right? And Fs is going to be equal to K, and we've been told K is 150, so it's 150 times 2D minus 1. Right. This is okay. This is good for now. So we can simplify this further if you wanted to. Okay, so we have this Fs. So now let's apply the summation of forces, the equilibrium equation for this joint B. So say summation of forces in the y direction equal to 0. This is B. So what do we have? We have 2t times the slope, and the slope is just d over 1 minus Fs. Okay, minus Fs is equal to 0. Okay, therefore 2t d is equal minus or is equal to Fs. What is Fs? Is 150 2d minus 1. And finally, our t, if we make t subject to the formula, it becomes equal to our t, if we made it subject to the formula, it is going to be equal to just 1 minute. Okay, so we have 150 2d minus 1 divided by 2d, like so. Okay, so this is what we have. Can I just rub, or can I go this side here? I think I'll need to wrap I'll need to wrap. So let me just write one part of t that I found. So we said one part of t is equal to 25 divided by root of 1 minus d squared. Okay, so let me wrap this so that I have some space. Alright, that's 25. Alright, like so. I wrap this. Okay, so Okay, there we go. So T therefore is going to be equal to 300D minus 150 divided by 2D. Then T becomes equal to 75, I mean not 70, 150, sorry. It becomes 150 here, then minus 75 divided by D, right? Okay, so we have now the two D's, this D and this D. We can equate the two. Okay, so if we equated the two, then we are going to have the following equation: 25 divided by root of 1 minus D squared is equal to 150 minus 75 divided by D. Okay, writing this as a single equation is going to be equal to 25 root of 1 minus D squared minus 150 plus plus 75 minus D is equal to 0. Okay, so let it be a function of D. So I'll say as a function of D, this is going to be equal to 25 divided by root of 1 minus D squared minus 150 plus, but the D, this one should be here, plus 75 divided by D, then minus 150 is equal to 0. So here we have this equation. Of course, there are a number of different ways you can solve this. For me, I'm just going to use the trial and error method. Okay, where I will have the number line like this: 0 minus plus. So I want to come closer to 0, so I'll need to find values of y. I mean, if I find a value of negative and another one positive, then I'll know to say my solution is in between those two values. Okay, I've used this method before several times, so I'll just need to, and then one thing to note before I do that, so I'll use trial and error. Trial and error, this is a method also. Okay, it's an accepted method that you can use, but you can solve this using whichever technique. Things to take note of: D cannot be equal to 0, because once it is equal to 0, this part becomes undefined. D also cannot be equal to 1. If it became 1, then this part becomes undefined. Okay, and again, D cannot be greater than 1, right? Because if it did, then this part becomes, this part here, it will have a negative value. So these are the cases. So it cannot be greater than 1. Okay, so therefore we know that our D, the only option for D will be greater than 0 but less than 1. Okay, so with this in mind, let's try out some values. Let's have the value of D here and the function of D on the other side. So let's try with 0.9. Okay, let's feed 0.9 in there. We see what we have. So it's 1 minus 0.9 squared, root of that, 25 divided by answer, plus 75 divided by 0.9 minus 150. So we have a minus 9.31. Okay, minus. Okay, let's try 0.7. 0.7 squared, 1 minus 0.7 squared. Okay, root of that, and 25 divided by answer plus 75 divided by 0.7 minus 150. We still have a negative. All right, 85. Okay, let's try 0.6. 1 minus 0.6 there. Okay, 25 divided by answer plus 75 divided by 0.6 minus 150. So we have a 6.25. All right, so we know that our solution is in between this 0.6 and 0.5. So get the average of that so that we see what we get. We need a value that is going to come closer to 0. So 0.7 plus 0.6 divided by 2 is a 0.65. So let's try this. So 1 minus 0.65, 0.65 squared, root of that, 25 divided by that, plus 75 divided by 0.65, minus 115. All right, the value reduces a little bit, 1.71. Okay, so we can still move to using the two, this one and this one. So average of that 0.6 plus 0.65, 0.6 plus 0.65 divided by 2. So we have a 0.625. Let's see what this gives us. 1 minus 0.625. Okay, square root of that, 25 divided by answer plus 75.625 minus 150. So we have a 2.02. So let's go for this. I'm sure our answer is being refined, this and this. So it becomes 0.625 plus 0.65. Okay, divided by 2. So this becomes 0.6375. I hope this one will get us somewhere. 1 minus 0.6375. Okay, square root of that, 25 divided by answer plus 75.6375 minus 150. All right, I think this is not bad, 0.09. I think we can settle for this. This is not bad. We'll say our D is approximately equal to 0.6375. You can go on if you want to. You can go on refining this solution. You can go on, but this is not bad. Our D is this, therefore, yeah, so we'll go for this one. Okay, our D is approximately equal to 0.6375 feet. Okay. Alright, I hope the video was helpful. If it was, give me a thumbs up, like my video, and continue sharing my channel. Bye bye, and see you in my next screencast.